All right, a couple more problems that were requested. So this one's out of chapter 3.7, or section 3.7. And so the first one is number 6, and we have to show that these two functions are self-inverses. Actually, they're just given this and saying, find that it's a self-inverse. So I'm going to call the other function g of x, and I'm going to do f composed with g and g composed with f. So, first of all, this thing's domain is all real numbers, this thing's domain is all real numbers. And I'm going to plug the g into the f, so it reads a minus x. And for g of f, I'm going to take the f and plug it in for the g, so it'll read a minus x. And you'll notice they look exactly the same. So I have a minus a plus x, which just leaves me with x's. And since the domain of the original functions were all real numbers, these are all real numbers. And so they are self-inverses. Okay. Now, I said something a little awkward there, and I need to be careful with that. This thing's domain is all real numbers. This thing's domain is all real numbers. Okay. And since it will accept all real numbers, and this will accept all real numbers, our inverses are safe. And when we're taking our function g and plugging it into x, all real numbers from g can go into f. All real numbers are nice to work with at times. All right, now, number 13. So first of all, we're going to do some graphical analysis. It says, when is this function non-decreasing? In other words, when is it increasing or flat? So I have a parabola, and this is shifted 7 units to the left. So the parabola is normally here as the base function. We shifted it 7 units to the left. It's asking when is it non-decreasing. So we're really getting at the idea of a one-to-one function, passing the horizontal line test. So if we just restrict ourselves to the non-decreasing component x greater than or equal to -7, and we'll call that our restricted domain, this thing behaves very nicely. So I am going to try and find its inverse now. And remember, we've restricted its domain to greater than or equal to -7. So I'm going to take the square root on both sides. I'm going to have the square root of y is equal to x plus 7. I'll move the 7 over, so I have square root of y minus 7 is equal to x. And for mathematical reasons, we flip the y and the x, and we end up with y is equal to the square root of x minus 7, or that's our g of x. Now the domain on this is naturally x is greater than or equal to 0. Now we need to do our composition, so we need to do f composed with g. So this is going in place of x, and we need to do g composed with f. So this expression is replacing the x here. And it's going to look like this. So I have the square root of x minus 7 plus 7, which is the square root of x squared. And since the domain of this is only greater than or equal to 0, this is going to pop out just an x, which is what we need for it to be an inverse. We take the square root of x plus 7, that quantity squared. Now the square root and the square, they get rid of each other, and it'll pop out as x plus 7 because we've restricted our domain. We don't have to worry about the potential of negatives being in there. So now 7 and -7 eliminate, and we get our x, and we have our domains appropriately defined. All right, and now for 16, it says show that these two functions are inverses. And we begin by saying the domain here is x can't be -2, and this one x can't be 1. And we're going to do f composed with g and g composed with f. So I'm going to take this expression, and it's going to go into the x here and here. So it reads 2x over 1 minus x plus, and it's over 2 plus 2x, 1 minus x. Got to get a common denominator, multiply top and bottom of this value of 1 minus x, 1 minus x, or by 1 minus x over 1 minus x. I now am able to distribute, and I have 2 minus 2x plus 2x. It's all over the common denominator. The 2x and the 2x eliminate, so I have 2x over 1 minus x over 2 over 1 minus x. I have a fraction over a fraction, so I'll copy dot flip. So I have 2x over 1 minus x times 1 minus x over 2. This 2 and this 2 cancel. 1 minus x is cancel, and I'm left with x. I'm going to do basically the same thing with the other direction. I'm going to take the f and put it in place of the x here and here. So I have 2 times x over 2 plus x, and I have 1 minus x over 2 plus x. I got to get a common denominator, so it's 2 plus x over 2 plus x because I'm multiplying by 1. I don't have anything to distribute in there. So I have 2 plus x minus x over the common denominator. So I have 2 plus x minus x here. The x's eliminate, so I just have a 2 over the 2 plus x. Copy dot flip, so I have 2x over 2 plus x times 2 plus x over 2. The 2 2's cancel. The 2 plus x, 2 plus x cancels. We're left with it equals x, and so they are the inverses of each other. We do need to check and see if this can generate a value of -2, and we need to check and see if this generates a value of -1. So I should do x over 2 plus x and see if that equals not -1, +1. Cross multiply, so I have 2 plus x equals x. I subtract x on both sides. That's not supposed to be an equals, that's supposed to be a subtraction. So I got 2 equals 0. Well, that's mathematical gobbledygook, so what it means is it can't happen. And then I'm going to do the other direction as well. So I have 2x, hold on folks. Sorry about that. Okay, so then I have to do the 2x over 1 minus x, and we're going to see if that is equal to -2 at any point. So cross multiply again, so I have 2x is equal to a -2 plus 2x. I subtract 2x, I subtract 2x, and I have 0 equals -2. That's, again, mathematical gobbledygook, so it can't happen. So our domains are as they stand, and we say when we're plugging into the G into the F, we take this one as the domain here, and we're plugging F into the G, we take this one's domain here. Okay, hopefully that's helpful.